one of the programs I wrote a while back. It's a Fennet software. So it had to call a tool offset right here. What they call a false tool. It's supposed to be tool 3, but Fennet for some reason makes you call a 200. I can simulate this. Do it step by step. Follow the code through the whole drawing, and I can speed that up just a little whenever I find my mouse. There we go. And it's reading the code and putting it into an image, looking for mistakes. Let's speed this up more. This is a pretty long program. Table's 5 foot by 12 foot. Had to drill a hole for a tabletop. It just entered the program. I'll pull up another program here. I'm gonna find my mouse. I think I got one on the desktop. This one was doing a part for PACCAR. This is for IKEA. For some reason they make you put a % sign in front of it. I'm not sure why. And your tool call, all that stuff. I run this one time. You'll see when it comes through, had to come through and do a deburr, and that's what you see, the wiggling back and forth. If I find X and Y, there. If you actually make a mistake on it, you can click on where you need to be at. I'll tell you where it's at, tool number. You got multiple mistakes, you can highlight, show you where it's at, show you spindle speed, feed, Z. Go down here to start computer, jump on my flash drive here. This is different companies. If I go through on-street programming, I had to go in one time, help Derek program a controller. There's your controller for the CNC. This is actually program all of your limit switches so the operator can't crash the CNC. You see all your datum points here. They should max min from 0. Your height offsets, your commons, your jog feed rates that you can go. Then you're gonna see all your inputs, and then all your outputs, min and max. There's all your inputs, outputs. You should be going to your global. Here's your global. This is when you get your output, it jumps to your little binary here to tell what step to do next. Like to kick on your brushes, your aggregate. Your aggregate is your actual tool tray, your vacuum to pick up the dust. Then you'll start getting into your drills, speed, min and max. So just all your your global here. All your tool speeds again here. Reason you got to follow in there because you got a drilling bank and a spindle, so you have to call an offset from the bank from the spindle. Then of course your height offset for your tooling. Your S2 is your spindle to your drilling bank. That's all your offsets from the S1, which is your tool holder here. I got, let me figure out where she's at here. Go to Unshrewd here. Your comp setting, you run off a controller. This is your band rate and all this stuff for your controller. Some more CNC programs, planing programs to zero out your table. That's a pretty cool program. I got a lot of other programs for that Kia. There's all your programs for your Kia. I actually got all the height offset coordinates for that. So when you write the program, that'll help you out. And your work coordinates, I got all that wrote down. You can actually call for, when you call for G54, G55, it goes those offsets automatically. And you can set those offsets to whatever you want to be. That's just some programs. Then I got my PLCs for Kongsberg. Some of them. It's a lot of programs. Ladder Logic, Allen Bradley. Here's a leak test cell. Let me open it up. It's going to open up a RS Logic, I think. No, I don't remember my password. 72188. Hold on. Let me pause this, get my password. I'm back. Got my password 72677. Okay. I tried to password protect all my programs because people like to go in there and edit, and I don't like anything to be edited. This is actually run through a binary, of course. Let me expand this up and here so we can see here. Not you. What's going on in my RS Logic here? There we go. This is my binary. This is what's going to actually go into your leak test. It runs different programs, and you try to operator idiot proof this as much as you can. This is some of it. Pretty long drug out program. All your serial port screen. Here's all your letter for your touch screen. This thing actually pull a vacuum and then do a pressure decay test and give a fail or pass. And we'll let the operator go any further if it failed until they figure out what the problem was. It's a pretty long program. Close that out. I got a bunch of stuff on here. Let me open up our RS Logic here. Let me open up some programs here. Here's one for automation of the cells, and it is password protected. So it's run off binary to subroutine, but it depends on the hardened plug. When you plug it in, I got it wired up so it automatically jumped to input 8, 9, and I just got the hot wire running to the hardened plug in there, and I'm on 2, 3. Then we go to the actual program itself. And because I don't have this one password protected, notice I don't have any comments there. I write down all my comments on a piece of paper. That's just to help me out. Here's some of them, what to do. If I can get my camera to focus in here. Well, that's some of them. I'll do that. In case somebody don't know what they're doing, go into the processor. They won't let them, they wouldn't know where to start at. That's just some of my programs. Like I said, all this is run off of binary subroutines. That's about it. We got a lot more that'll cover it.